All right, so this is lesson 5, our very first screen recording, and I'm going to roll through this as quick as possible. If you need a little assistance, just press pause and or rewind it. So let's jump into it. Computer-related issues. A couple things we're going to go over today. We're going to go over defining the problem-solving system, and we're going to identify the different steps of doing it. We're going to take a look at the identifying criteria for selecting and buying a computer. We're going to talk about warranties and support agreements. We will go over the idea of what a useful life for a particular computer might be, and then we'll explain the process of discarding equipment and why you might want to note doing that a specific way. So a couple things you need to know vocabulary wise for this lesson. Linux PC, that's going to be something we're going to go over. Problem solving, support agreement, troubleshooting, we're actually going to define that term. Well, you'll understand the term useful life of the computer and the warranty. So we'll go over those various things. Just a quick introduction on this. You've had computers, you've had computer issues. They could be in relation to possibly a hardware issue or even software issues. So knowing and figuring out how to get to those solutions are important. So we're going to basically take a look at how to reach a solution, correct those problems, and the process involved with that. The problem solving obviously is a systematic approach in order to get to the solution. But you know what? There are some restraints. There are some things you can do and some things you can't do. So taking a look at that. The first thing we'll talk about is the problem solving process itself. The process of solving a problem is a logical system. It's a logical plan. It's a way of doing something. It's the same way every time. First of all is define the problem, then investigate and analyze the problem. And what I mean by that is, we're going to go into detail on that actually, so I don't want to elaborate right now. Identify possible solutions, select and implement a solution, and evaluate solutions. As I'm looking at this, I'm thinking, this looks a lot like the the scientific method. Remember the thing you learned in the 6th grade? Doesn't this look a lot like the scientific method? Yeah, it's pretty doggone close to it. I think that'd be a cool project, maybe doing a compare and contrast with that, so that might work out real good. But this whole problem solving process actually has a term, and it's one of our vocabulary words, and it's troubleshooting. Okay. So let's take a look at this in detail. Define the problem. You have to ensure you actually have a problem. Okay. If you turn your computer on and it doesn't come on, do you have a problem? Well, you know what? It might not be the computer, because if you didn't pay the electric bill, that might be the problem. So isolating, kind of defining that you actually do have a problem is the very first step. Obviously, if you go to print something and it doesn't print, then yeah, you've got a problem somewhere along the line. So you've got to go on to your next step, which is investigate and analyze the problem. You have to collect data. You've got to figure out, hey, what's going on here? I understand that it's not printing, but why is it not printing? Is it because the printer's not on? And a great way of analyzing and collecting data is simply, one way of doing that is actually going onto the web. Or, the first thing I do when I have a problem with anything is I Google it. I say, hey, is anyone else having this problem? And you'd be amazed how many people do. I saved so much money on my pool pump because it was making a noise, and I said, oh wow, I wonder if anybody else is having this problem. So yeah, I Googled it and found out, yeah, a lot of other people are having this problem. The guy at the pool store said, oh yeah, you got to get a whole new pool pump. Well, you know what, that's what was that, $1,100? I'm like, I don't want to do that, and then I got to pay for somebody to come out and do it. Ended up doing some research, analyzing the data, found out that it was a $250 fix. Okay, heck of a lot better than $1,000. So get some information, process that information, figure out what's going on, determine why the problem exists, and what are some of its possible causes. Ask questions, help identify all the possible solutions, starting with the most basic. If it's, hey, is the printer plugged in? Is the printer hooked up to the computer? Does this computer work with that printer? So there's lots of little basic steps that you go through one by one to get to more difficult possible solutions. But start with the easy ones first. Okay. Select and implement a solution. You've got to do trial and error. That's all it boils down to. You've got to find out what works and what doesn't. Okay, I don't have a light on the computer and it's plugged in. What if I plug it into another receptacle in the lab? And then if it starts working, guess what? The problem's not with your computer or not with the printer, it's with that receptacle. Okay, so you've been able to isolate that problem away from the computer. You've been able to determine if there really was a problem with the computer, but you wouldn't have known that unless you tried different things and implemented it. Okay, so that's something you need to be aware of. Confirm your solution. If you've done some stuff and it works, great. Can you repeat it? Because if you can repeat it, then the likelihood is that, yeah, you did fix it. But for example, if I can make something print by turning the computer off and then turning it back on, and something prints, but then when I hit print for another document, it doesn't work, well, I've got a problem there. Okay, it's something's not working quite right. So I didn't really fix it. I just kind of put a band-aid on it. I was able to get my project turned in, but I didn't fix the problem with the computer. Okay, so you do have to document what you've done and then what the solution is, what your result was, and so if it ever happens again, okay, then somebody else either knows how to fix it, or the first thing is, if you ever call customer service or something like that, the first thing you're going to say is, what have you done? And you can go bam, 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 these are the things I've done, and you know because you've documented it. Okay, problem solving, that whole process, it is not what they call a linear process. You're not just going to go down the line one time and get to the problem. Unfortunately, with computers and hardware and software and all the different things that goes into that, it's what's called a spiraling technique. And what it means is that, you know what, you may have to turn that computer off 10 times to get to the solution. You may have to turn that computer off 10 times and back on 10 times, and then you may have to reinstall or reprocess the software 9 times. And so you're going to have to keep stacking on top of what you learned last time. Okay, it's not the plug. Okay, so I can move on. Now that I know this knowledge right here, I can move on to maybe something a little more complicated. So that's why you see the spiral thing right there, is that we sometimes have to repeat the different things. You may have to turn your computer off and on and go through different systems in order to get to the true problem. So it's a spiraling process, not a linear one, unfortunately. So following the steps on how to implement troubleshooting for a problem, I pretty much did that with you already. I am not going to insult your intelligence by reading these slides to you, and but if you want to read them, I'll let you do that. But we've kind of already talked about that. So identifying problems, hey, that's just trial and error. Again, selecting and implementing a solution. Isn't that kind of like forming a hypothesis, doing an experiment? Again, we're talking about 6th grade science here. Great project. Confirm the solution, document what you've done. Okay? Moving right along. Consumer issues. All right? If you're going to purchase or maintain a computer, it's going to require research. You know, why? Well, do you want to drop $1,500 on a computer that maybe you don't need? Okay? If you're just needed to surf the web and maybe send emails, maybe you just need a netbook for that, or an iPad. You don't need, a $2,000 supercomputer. It's not a supercomputer, but you don't need a big old computer for that. Okay? You don't need the iMac Pro or the G6 or whatever they are nowadays. Okay? So you don't need to drop a whole bunch of coin on that just to do something simple. Okay? You might be able to get by with your iPhone. Okay? So purchase a computer, again, identify the purposes and the tasks of what you're looking to do, and then maintaining a computer also may require a little bit of knowledge on your end. Who's going to be maintaining this computer? Is it going to be you, or is it going to be someone in a lab? Okay, if it's an iPhone, you probably don't have a whole bunch of maintenance issues. Okay, they're kind of a disposable item anyway. But if you're investing $40,000 in a server, you might want to take a look at, maybe I should have a maintenance contract on this. Okay, is it worth an extra $100 a month for somebody to come out and make sure everything is running smoothly? Probably so. Okay, and that's where you get into things like warranties. Okay, if I buy this from this company, if everything works correctly, as the way it should, let's say that the product meets certain specifications, but if it doesn't, then the manufacturer a lot of times will replace it or repair it. So not a repair guy. So your warranty will spell out those specifications that the computer should meet. And if it doesn't, then that's what you want to take a look at, possibly having a warranty. So those are decisions that you have to make. Do I want to buy this computer off of Craigslist, or is it worth it to drop an extra $100 to actually go get a new one and have a warranty on it? So those are things you have to think about. Support agreements. You know what these are. When you go to a place like Best Buy, they put a service agreement on everything, a support agreement. I went to buy a pack of gum one day and they asked me if I wanted a support agreement on it. I told them no, not really. But this is the absolute truth. I just bought a coffee pot from Kmart. The coffee pot was $20.49. They asked me if I wanted a support agreement on it. Okay, the support agreement was $19.99. No lie. I told them I'll pass. Okay, but a support agreement, bottom line, is a specific, it's services specifically designated to provide assistance to a company or to an individual or an organization to basically have, if something was wrong with the particular device, then they'll fix it based on an agreement, that a pre-purchased agreement usually, or it may be a support agreement where we have a certain company who comes in and maintains our computers. So those are things that most of the time are purchased not from the manufacturer, but from local vendors or from the place where the company where you actually bought the merchandise. So a useful life, let's talk about that real quick. Useful life of a computer. How long is this thing actually going to be considered useful? Is a computer from 1986 considered useful today? No. Why? Because the average life in comparison for a piece of technology in comparison to humans is 10 years for every 1 human year. So if you have a 7-year-old computer, it's like trying to do something with a 70-year-old. Okay? Now I don't mean anything bad against 70-year-olds, but Pawpaw can't go out and run 50 yards and lay out for a football like he used to 30 years ago, 40 years ago. Okay? It's not expected of him to be able to do that. So if you're using a computer that's 7 years old, it is not going to stream Halo as quick as it should. And so if you're lagging and getting killed all the time, it's because you got an old computer. Okay? It wasn't made for that stuff. Its usefulness has lived out its lifetime. Okay? So you have to upgrade, unfortunately. All right, and then the last thing is discarding equipment. The EPA, the Environmental Protection Agency, is a company, it's a governmental entity, and they make sure that the soil is not polluted. Okay, so there are parts in computers that if you just throw them out in landfills, unfortunately they leak that stuff into the ground, and unfortunately, drinking water and things like that, and possibly they don't break down and decay like pieces of paper do. So there's certain ways to dispose of computer equipment. I would like for you guys to do some investigation. What parts of the computer are not degradable, biodegradable? Okay, what parts maybe can be recycled? So those are some great inquiry type stuff, but just let it be known that discarding of computers is a pretty prominent issue we have nowadays. Think about how many old computers we have. Okay. So in summary, I'm not going to read all this stuff to you. I'm just going to flip through these slides. If you want to pause and read what we've just talked about for the past 10 minutes, please feel free to. But I can tell you this, I am very much looking forward to some of the ideas that you guys have thought of on what you're going to do on your project-based initiatives. I'm very excited on how this whole program is laying out. We're going to have a great time with this. I think you guys are really going to be able to reinforce some of the stuff that we've talked about in this little presentation, and then you'll also be able to reiterate that information back to me, which is going to confirm that, hey, you know what? This is working. These guys are getting this information, and they don't need me up there. Yeah. Okay, so good luck with this. I will see you in class tomorrow. Be ready to choose your project path. Either do it on your own, do it with a group. I highly recommend a group because it's a lot of work to do all by yourself. But and choose your group. You can choose a partner, 2 or 3. I don't want to see huge groups, okay? Because then work gets so watered down that you have 2 or 3 people sitting around doing nothing, okay? And that's not fair to anybody. So I'm going to end this presentation, and I will see you guys in class tomorrow.